When curve sketching, we'll do the following steps: find domain, find intercepts, determine symmetry, find asymptotes, find intervals of increase or decrease. That will give us local maxes and mins. Then we look for concavity and inflection points, and finally sketch the curve. For example, let's sketch the graph of f of x. Step 1, we'll look for domain. In this case, the domain is simply all real numbers. We're looking at a polynomial which has no restrictions. Step 2, we'll locate intercepts. The x-intercept is found by forcing f to be 0. Want to make your y values 0. We'll factor and then set each factor equal to 0. And solve those. We get x equals 0 and x equals -3. So we have the origin and -3, 0. To find y-intercepts, we simply make all of the x's 0. So we have 0 cubed plus 3 times 0 squared. F of 0 is 0. So again, we have the origin. In step 3, we're going to look for symmetry. To do this, we'll start by evaluating f of -x. So replace all of the x's with -x. This gives us -x cubed plus 3x squared. And so notice that f of -x is not the original f of x, so we can say that this is not an even function, which tells us it is not symmetric about the y-axis. To check to see if it is odd, we'll take this result and factor out a -1. So negative x cubed minus 3x squared. We factored out a -1, and now notice that f of -x is not negative f of x. This means it is not odd, which tells us that the graph is not symmetric about the origin, so it looks like we're not going to have any symmetry to help us graph. Step 4, we're looking for asymptotes. And in this case, there are no asymptotes because we are looking at a polynomial which has no restrictions on its domain. In step 5, we want to find the first derivative to help us find intervals of increase or decrease. So f prime is 3x squared plus 6x. We'll set that equal to 0 and factor. Set each factor equal to 0 and solve. And we'll use these 2 points to help break up our number line for our intervals to test. We have the interval below -2, the interval between -2 and 0, and then the interval that is to the right of 0. Next, we'll look at our factors, what that tells us about f prime, and what that tells us about the original f. So 3x, looking at that factor, to the left of -2, that factor is negative. Between -2 and 0, negative. and to the right of 0, positive. Then looking at the factor x plus 2, in the first interval we have a negative, and then a positive, and then a positive. So f prime is positive on the first interval, negative on the second, and positive. That tells us that f must be increasing in the first interval, decreasing in the second, and then increasing again in the third. This will give us step 6. Notice that you have a change from increasing to decreasing at a value of -2. So we can evaluate f of -2, plug -2 into the original function, and we see that the value is 4, giving us a local max. We can also see that f is decreasing and then increasing at a value of 0. So f of 0, plug 0 into the original, and we actually already did that when we found the intercepts. We know that 0, 0 is a local min. And finally, in step 7, we want to take the second derivative, that is 6x plus 6, and set it equal to 0 and solve. Factor out a 6, and then solve x plus 1 equals 0, get x equals -1. And again, we'll do some testing. We're looking at the interval to the left of -1 and to the right of -1. We'll look at the factors, 6 and x plus 1, what that tells us about the second derivative, and what that tells us about. So 6 is always positive. To the left of -1, x plus 1 will be negative, and then positive. That tells us the second derivative is negative on the first interval, positive on the second. So we have concave down for f on the first interval, and concave up for f on the second interval. Notice we do have a change in concavity at -1, so we can look at f at -1 and see that we have an inflection point at -1 too. And now sketching the graph, we'll go in and put in all the important information that we found. We know that there is an intercept at 0, 0. There's an intercept at -3, 0. There's a local max at -2, 4. And a min at 0, 0. We know there's an inflection point at -1, 2, where it changes concavity. Remember, the function is increasing from -infinity to -2. Then it starts decreasing from -2 to 0, and then changes concavity from concave down to concave up at -1, and then starts increasing again. And keep in mind that we can check this in our graphing calculators to make sure our sketch looks somewhat close to the real graph.